Here we go, arithmetic sequences. Section 2. We're going to define, identify, and apply arithmetic sequences in this section. So, an arithmetic sequence is a sequence where the difference between consecutive terms is constant. This difference is called a common difference. So in this sequence, 2, 6, 10, 14, 18, 22, we can write a recursive version of it, or we can write an explicit version of it. If we do the recursive version, remember the recursive is always based on the previous term. So what's the change happening here? Is it a common difference? The difference between those two is 4, the difference between those two is 4, and so on. So the common difference is 4. So what you would do, a sub n minus 1 plus 4 would get you the next term. But in the explicit version, that's the one where we have to be able to find any term based on the number, like the 5th term or the 8th term or the 22nd term, not with respect to the previous term. So for this one, we know that it's going to be 4 times n, and then we have to figure out what it's being added to it. So I'm just going to do a little bit of trial and error. Let's see. Well, I guess I could just do it pretty straightforward. If I were to choose a sub 2, then 4n plus what would give me a sub 2? A sub 2 happens to be 6. So I'm going to replace, well here, I'll just keep that. A sub 2n. And then I'll do a sub 2 is 6. 4 times 2 plus a, and I'll solve for that a value. So that's going to be 6 equal to 8 plus a, and then we will subtract the 8, and you'll get negative 2 equals a. So then you could say that a sub n equals 4n plus a negative 2. So I was trying to figure out what I needed to put in this position right here. And that should be the explicit form. And we can test it for the, let's see, this is the 1, 2, 3, 4, 5, 6th term. So is a sub 6 going to give us 22? So 4 times 6 minus 2. So that's 24 minus 2, which is 22, which is the 6th term. So that's one way you can go about it. Or you can use this formula that's going to work every time. So the recursive I gave you, it's always going to be the previous term plus 1. The explicit, if you have the first term is a, so I have a sub n is equal to a plus n minus 1 times the common difference, and then we can solve for a, because we're going to get d from the sequence. So is this sequence arithmetic? Is there a common difference? Yep, okay, so the common difference is 3. So let's write an explicit form for it, which would be a sub n equal to a plus n minus 1 times 3. And if you wanted to choose, let's just choose a sub 4. So a sub 4 is going to equal a plus 4 minus 1 times 3. But what is a sub 4? A sub 4 is 12. So I guess I could, well, so a sub 4 is 12. And let's solve for a. Subtract 9, and we get 3. So I'll get a sub n equal to 3 plus n minus 1 times 3. And then let's do the distributive property. And then combine like terms. So 3 minus 3 is 0. So I just get 3 in. So now let's check it and see if it works for, I don't know, you do a sub 2. So if I'm checking a sub 2, 3 times 2 is 6, which is the second term. If you wanted to check a sub 5, we would get 3 times 5, which is 15, which is the fifth term. So I think we're good saying that that is our explicit formula. So let's see about this one. Is this an arithmetic sequence? Well, the difference between those two is 3. The difference between those two is 5. 7. Not the same, right? So this one is not an arithmetic sequence. So we're not going to be able to do anything with that one. We're going to move on. Hello? Okay. So we're going to find the 100th term of the sequence, the arithmetic sequence that begins with 6 and 11. We are told that it is arithmetic, so we're going to believe that it is arithmetic and just follow the process. Now, you've got two options. The formula that I gave you looks like this. And when I did it for you on the very first example, where I didn't give you a formula, I just said, here, let's figure it out, it looked like this. And either way, you're going to get the same answer. This letter, it can be anything. I think on the first example I had an A, but you can label it anything. It's just not the same A as this A. So I'll do it this way, and then I'll do it this way, and then you can choose which way you want to do it. So for the, I don't know, I'll call this is A sub 1, this is A sub 2. If I use A sub 2, I'm going to have A plus 2 minus 1. The common difference, well, the difference between those two is 5. So A sub 2 is 11. 2 minus 1 is 1. Solving for A, we get this. So then you'll have A sub n equal to 6 plus n minus 1 times 5. And then simplify that. So you'll have 6 plus 5n minus 5. And then you'll get 6 minus 5 is 1. And there's your arithmetic sequence. Now, if you're doing this version of it, A sub 2 will be common difference times 2 plus some unknown c value. A sub 2 I know to be 11. 5 times 2 is 10. Subtract that 10 and you get 1. So we get A sub n is 5n plus 1, which is the same thing we got down here. And then I would probably check it just to make sure it works for the other term. So I'm looking for A sub 1. Well, what's 5 times 1 plus 1? 5 times 1 plus 1 is 6, which matches with A sub 1. So both of these versions get you the same result. It kind of reminds me of if you're doing point-slope form versus slope-intercept form. Slope-intercept form, you solve for c and then plug it back in. This one you have to go a little bit further. So, anywho, either way will get you there. We have something called an arithmetic mean, or average, which is just the average that you know. There's something else called a geometric mean, which is different, but we'll get there when we get there. So arithmetic mean, or average of two numbers, x and y, is the sum of those two numbers divided by 2. So what is the missing term of the arithmetic sequence that we just have a portion of? We've got 15, we have an unknown, and we have 59. So if we're trying to find that term and we know it to be arithmetic, you can add those two together and divide by 2. So that's going to be 74. 74 divided by 2 is 37. So that's the missing term. And we're done.